Is everybody letting in automatically, or do you have to let them in?
No, they're going to be let in automatically.
Just tell me when you want me to get going, Natalia.
We can go ahead and get started around 9 o'clock. I see quite a few people joining us now as attendees. So I'll let you guys know we have 5 people so far, but we had, again, almost 50 people registered. So let's give them a few minutes to join us. Let's go ahead and get started.
All right, thanks, Natalia. So I want to thank you for joining us for this webinar dedicated to commercial real estate's industrial sector. As you all know, industrial commercial real estate is booming here in Houston and elsewhere. As a result, Houston BOMA convened a special interest group for industrial members in 2021, and we'll be launching several new initiatives and programs targeted at industrial throughout this year. If you'd like to get involved with the Industrial Special Interest Group, I do encourage you to reach out to our Membership and Professional Development Manager, Natalia Lara. She'll drop her email in the chat. We'd love to hear from you. For our first industrial program, we've asked Bob Caputo, President of the American Fire Sprinkler Association, to join us to talk about high pile storage requirements, storage permits, and more. As president of AFSA, Bob is responsible for providing guidance and support to the association's board of directors, while leading AFSA's experienced team of engineers and professional staff dedicated to serving the contractors, designers, manufacturers, suppliers, and authorities having jurisdiction represented by the organization. He also represents the association with key stakeholders, including regulatory and other public agencies, and oversees the association's efforts to promote the utilization of automatic fire sprinkler systems in the US and around the world. Bob is a well-known industry expert, presenting on hydraulic calculations, fire pumps, plan review, and Nfpa standards for the American Fire Sprinkler Association and the National Fire Protection Association. He chairs and serves as a member on several Nfpa committees, including chairing the Nfpa 16 Technical Committee, Nfpa 24, and Nfpa 2291. He has contributed to the Nfpa 13 and Nfpa 25 handbooks and developed many AFSA programs, including its project management tools and inspector testing, maintenance, inspector development programs. Additionally, Caputo has chaired 2 chapters of AFSA, Arizona and Southern California. Bob serves as a member of the Oklahoma State University School of Fire Protection Engineering Advisory Board. He is the recipient of numerous awards, including the Fire Protection Contractor Magazine's Industry Person of the Year, San Diego County Fire Chief Association's Fire Prevention Officer of the Year, and AFSA's highest honor, the Henry S. Parmalee Award. Caputo attended Chapman College, Orange, California, and University of Albuquerque, New Mexico. He is a U.S. Navy veteran and former volunteer firefighter. We want to thank you, Bob, for joining us today and providing us with your expertise. For those of you that are interested, we will be providing a PDF copy of the presentation to all registrants. If you have any questions, throughout the session, please feel free to submit them in the chat. We will monitor those and have them answered as time permits. And please help me welcome Bob Caputo, President of the American Fire Sprinkler Association.
Thank you, Bradley. I appreciate that introduction. We're going to have to cut that down by a few minutes. I actually thought we were going to be talking about high gas prices and global politics today, but since Bradley asked me to talk about fire protection and fire sprinkler systems in industrial and storage applications, I guess we'll go that way instead. So today I want to talk about a little bit of the history, some storage concepts and design approaches, as well as what you need to know about hydraulics with fire protection systems and applications. The reason that, well, first let me say this, there's no way I can make any of you experts in an hour's time as it relates to fire sprinkler systems and as those fire sprinkler system design criteria relate to a tenant or an owner's application or need. What I would like to be clear about is that not all fire sprinkler systems are the same in terms of their design. And what I mean by that is the higher the fuel load, the closer my industry spaces the sprinklers and the more water we put out. So in other words, when we have a fire, we have a fuel load that creates a heat release rate. The higher the heat release rate, the greater demand for water so that the sprinklers can control the fire or perhaps suppress the fire. So in this picture, we're looking at 1920 era storage that was relatively low. And you can see these whiskey bootleggers only stack these boxes as high as they can reach above their head. Today, we see storage applications with automated retrieval systems that exceed 50 foot in height in some cases. The reason for that is simple. Back in the 30s and the 20s, we didn't have the kind of equipment, lift equipment, or storage handling material equipment that could reach very, very high. As technology developed and forklifts were able to go higher, retrieval systems are developed, the higher we can store things. So that's one impact, the height of the storage, because fire moves both vertically and horizontally. And the rapidity at which that fire grows tends to have the strongest effect as the fire moves upward. So now I've got this raging fire in a very tall storage facility, and the heat release rate is so intense that in the early years of standard fire sprinklers, no matter how much water the sprinkler put out, the droplets wouldn't reach the base of the fire. They literally would evaporate before they got to the bottom. So this higher challenge caused the need or drove the need for better technology. That technology results in different kinds of sprinklers that are both larger and put out larger water droplets that are heavy enough to fall through the plume or the hot rising air so that we can attack the fire and control that fire by limiting its spread until first responders show up and complete the job of suppressing that fire, evacuating the smoke, and so on. So the critical thing, whether you're a leasing agent working with a tenant to try to place a tenant in a building, and really the theme of what I want to talk the most about is you put the tenant in the wrong building in terms of the ability of the fire sprinkler system or the robust nature of the design of that system, the tenant is mismatched. And either their insurance company or the local authority, the local fire prevention officer is going to cause a lot of pain and consternation because the fire sprinkler system is going to have to be upgraded before the tenant gets a certificate of occupancy. So let me start with the basics. There are 4 basic types of fire sprinklers systems, And you will probably most likely only be dealing with wet pipe systems, which are the most common. There's always water in the piping system, and the sprinkler heads are distributed throughout the building in a pattern on the branch line piping. So water's in the pipe. And so the only rule here is that the temperature within the building, excuse me, has to be maintained at or above 40 degrees Fahrenheit or 4 degrees Celsius. For those of you who may not know this, these sprinklers are individually heat activated at a preset temperature. Some are as low as 155 degrees, others are as high as 500 degrees. The standard in most warehouses is going to be 286 degrees. These sprinklers operate fairly quickly, and the differentiator in temperature at the ceiling level, getting from the 155 to the 286, is pretty much instantaneous. Very few seconds are needed in the fire between, those two temperature gradients, if you will, to set off or operate those sprinklers. When you have a tenant or a location where you can't maintain the building at or above 40 degrees, such as unheated attics and warehouses in, let's say, parts of Texas where freezing actually occurs, which is usually not Houston. A dry pipe system has compressed air or nitrogen in the piping. When the sprinkler activates, instead of the water instantaneously flowing like it does in a wet system, there's a delay in delivering the water because the water has to push the air, compressed air or nitrogen out. But then again, it operates just like the wet pipe system once the piping is flooded. Pre-action systems are like a dry pipe system, but it incorporates a detection system, whether heat detectors, smoke detectors, rate of rise detectors, beam detectors. There's a host of a variation of detection systems. But in my pre-action system, I need both the heat to activate the sprinkler and the smoke, or whatever the detector is designed to do, to also send a signal to a panel that says I have two functions. I have the heat for the sprinkler, and I have the detection system function that opens the valve through a solenoid and then floods the system. Most of my sprinklers are still closed, but the open sprinklers are then going to flow water. Now, in my pre-action and in my dry pipe systems, I have a bit of a delay, about 60 seconds or less, before water hits the floor and acts on the fire. So in those cases, my design area is going to be a little bigger. And again, sometimes I get in the weeds and tell you too much information. Here comes my deluge system. In a deluge system, which we really in the industry call a Hollywood system, because this is how Hollywood depicts fire sprinklers. Arnold Schwarzenegger lights a cigar in the elevator and all the sprinklers in the parking garage goes off, which is absolutely ridiculous, by the way. But this is an example of a deluge system. In this case, the nozzles or sprinklers are all open. And when my detection system opens the valve, then all the nozzles are going to flow at one time. This is an LNG tank out in the yard. And what this system is doing is cooling that tank so that an exposure fire doesn't superheat what's in the tank, which in this case, liquid gas that would be heated, it would expand. And this is called a BLEVE, a boiling liquid expanding vapor explosion. If you've lived in Houston and are older than 50, you might remember down in Baytown, they had a big tank farm where they were processing petrol, various chemicals and mostly gas. And they had this big explosion. So certainly South Texas, Baytown and Galveston have a lot of these refineries. And so you'll see a lot of those kind of systems. These are usually not seen in a warehouse. So the first thing the designer of a system needs to know is, what's my water supply? Am I going to use the municipal water supply, or is that inadequate for my need for this warehouse use? If I don't have enough pressure, I'm going to add a fire pump. And that fire pump is going to boost the pressure from the city pressure to the pressure that I need for that particular fire sprinkler system. If I don't have enough water, the volume of water is inadequate, I can add a water storage tank. And of course, the fire pump, which in the bottom right picture, you see this little house next to the water storage tank. In that case, the pump is going to move the water from the tank to the system and of course impart pressure. You might in your travels find gravity tanks, pressure tanks, but the pump can draw water from lakes, rivers, ponds. If you've been to the Bellagio Hotel in Las Vegas and seen the big water display in front of the hotel, well, that's actually not there for the water display. It's actually there for their fire protection systems. And the architectural team decided, well, if we have to have this big lake of water for the fire protection, we might as well make it an attraction. Regardless, the primary considerations for the protection of storage occupancies are these four things. What are they storing? What's the commodity classification based on the Nfpa 13 standard? How is it packaged and what kind of pallets do they have? Because the total of the heat that will be produced by a fire impacts not only the product, but the packaging and pallets, which can be metal, wood, or plastic. Plastics give the most amount of heat. So I'll put it this way. If I burn a block of wood that weighs 1 pound, the BTU, British thermal unit, measured by that 1 pound of wood is going to be around 8 BTUs. But if I take 1 pound of plastic, group A plastic, poly something, polyurethane, polyethylene, polystyrene, if I take that plastic and burn that same 1 pound, my BTU heat release rate is going to be just shy of about 20 BTUs. So really almost 3 times more heat. And you may or may not know this, but there are way more plastics used today. When you talk about petrochemicals, almost everything we have, from our cell phone to the television we watch, the synthetic materials of your draperies, the foam cushions that you're sitting on, are all made of byproducts of oil, right? Of crude oil. So when I have plastic pallets instead of wood pallets, my heat release rate is going to go way up. Now my fire sprinkler system has to be more robust. Now I mentioned plastics, and for just a moment, I also want to note that there are non-expanded plastics like my phone or my phone case. And I have expanded plastics, which are styrofoam or polyurethane foam cushions, like your sofa at home. So the expanded plastics tend to burn much hotter, much faster. And when they burn, they drip and take the fire from those higher pallet loads or pallet racks, and they drip this stuff down on the lower levels, and they make that fire grow much faster. So how things are stored, whether you're on pallet racks or palletized on the floor or what we call solid piled, these fires are going to burn differently, have different heights. So I need to know how high will I be storing and how tall is the building into which I have the storage. So the more clearance above the storage, the more the fire is going to spread the heat to a larger cone shape, if you will, at the ceiling level and open more sprinklers. If you don't take anything else away, I want you, as if you're a leasing agent or if you're in these warehouses, especially if it's a new client for an existing system, you're going to find this hydraulic placard on the risers of the sprinklers system, the vertical pipes that feed the overhead pipes that take the water from the underground mains up to the ceiling level. This sign is critical for you to know what is that existing system design. And I would encourage you to grab your smartphone and take a picture of this sign on each of the risers. That way you can talk to whomever, whatever expert, fire protection expert you're dealing with, and you can explain to them, hey, these are the systems in this building. This is what my client's going to be doing in this building. Can you tell me if it's adequate? That's going to save a lot of time and energy for somebody to make the evaluation, not to have to visit the building, have you come back out, unlock it, and let them go look at this placard. This is called the hydraulics design placard, and there'll be numbers on this thing that look like a 0.33 for 3,000. This is design criteria and information that a fire protection person is going to understand. But it basically tells you how much water is going to come out of each sprinkler and how large of an area that it applies to. So what I'm talking about there is, other than the deluge system I described earlier, fire sprinkler systems are not designed to spray water over the entire building. The water supply is only adequate for a small area. So let's say we had a fire sprinkler system that's designed for a 3,000 square foot area. If the building is 80,000 square foot big, the fire sprinkler system only has enough water and pressure to deliver the water needed to a 3,000 square foot area of that building. And by the way, in warehouses, a fire sprinkler system can only cover 40,000 square foot of floor area. So if you have an 80,000 square foot building, you're going to have at least 2 fire sprinkler systems in that building. The reason for that is when we take a system out of service, we don't want to take the entirety of a large building out of service. Also, in some cases, we require in-rack sprinklers for those large storage facilities with pallet racks that go pretty high. So in those cases, the in-rack system is going to be separate from the piping system at the ceiling. So you will have multiple risers or multiple systems within each building, and that's very, very common. So again, my fire sprinkler system is going to be based on this commodity classification, which includes the product itself, plus the packaging, plus the pallet type. The fire sprinkler system designer is going to take that commodity classification and then evaluate the storage method and the storage height and the building height and come up with a prescriptive based design for the criteria of that particular client within that particular building based upon the Nfpa 13 standard. For those of you who might not know, Nfpa stands for the National Fire Protection Association, and they produce all of the codes and standards for fire protection systems, for electrical systems that are installed in buildings, pretty much any facility that are referenced by the ICC or International Code Committee or Council. In addition to, and again, guys, I know you asked me what time it is and I'm telling you how to build a clock. I'm not trying to make fire sprinkler experts out of all or any of you, but I want to give you the building blocks. Excuse me. I want to give you the building blocks so that we understand the end result. So there are 3 basic types of sprinklers. CMDA, which is called control mode density area sprinklers. They're standard sprinklers. If you're in the office building right now, look above your head. You're looking at a chrome semi-recessed or chrome pendant sprinkler. That's a control mode density area sprinkler. The sprinkler is designed to control the fire and limit its regrowth. It's not designed to extinguish the fire, although that does happen more often than not. The next is called the CMSA, which is an acronym for Control Mode Specific Application Sprinkler. It is a sprinkler specifically designed for storage applications. And lastly, we have the ESFR, which is called an Early Suppression Fast Response Sprinkler. Larger sprinklers deliver more water at the same pressure. Excuse me, and the ESFR sprinkler is the latest technology to allow storage at greater heights without having to put in-rack sprinklers in. Customers hate in-rack sprinklers because when they go to move the racks, the pallet racks, they have to also shut down the sprinkler system and move the piping. Also, it's not uncommon for a forklift driver to hit the sprinkler or the sprinkler pipe and break it, causing significant flooding within their building, and nobody likes that. sprinklers in racks, excuse me, do have a protective cage on them, but that's only designed for the bumping by a handheld box. It sure as heck is not going to protect that sprinkler from the forklift. Think Bambi versus Godzilla, with Bambi being the sprinkler and Godzilla being the forklift, and you'll get the mental image of how that impact works. So just real quickly, a class 1 commodity is a non-combustible product, whether you the wire or the concrete you see here in this picture, and that's generally stored on wood pallets or in corrugated containers with single thickness. A class 2 commodity is also non-combustible product, but with a greater amount of packaging. Wood crates or boxes, multiple layered corrugated cartons, or multi-layered cardboard dividers. Now you might ask yourself, why in the world is Bob telling me this level of detail? The answer is, I want you to see that these subtle differences in the carton or the container are going to drive a different requirement for the fire sprinkler system. So if you're moving a tenant into a building, we need to know a lot of specific stuff so that we can understand what the fire sprinkler system needs to be. Is the existing system adequate, or will upgrades be needed, and how will those upgrades be handled before your tenant can move into the building? Class 3 commodities are ordinary combustibles in cardboard boxes or on wood pallets with a limited amount of plastic. Class 4 products are all of the prior products, but now there's a more substantial amount of Group A plastic packaging or within the product itself. And then, of course, I have all these Group A plastics, and again, expanded and non-expanded. So natural rubber, nitrile rubber, nylon, but anything that says poly something is going to be a Group A plastic. Very few tenants don't have Group A plastics. So the higher the classification, the more heat release rate I get. So the more robust my fire sprinkler system needs to be. Now, there are things that are not addressed by NFPA 13. First of all, you can't have storage in a building where the ceiling slope is greater than 2 in 12 or 16.7%. So you can't have a storage application in a Quonset hut. You can't have shelf storage over 15 feet, which is probably not something you care about. But whoops, most importantly, and I got to go back to that slide, sorry. There are some things we don't give you criteria for in the standard, including these pods, right? So all the combustibles are hidden in these containers, and the heat is not going to get to the sprinklers, and the water is not going to penetrate this metal box to go attack the fire. Things like boat storage on racks, but these overseas containers indoors, these are the kind of things that make life tough. Some warehousing operations have lots of different products. So I will just say that we base the protection criteria on the worst case scenario, as opposed to figuring out, well, I have this mix here and I have that mix here. What ends up happening if you try to do that is that the tenant changes their operational functionality and they start moving the higher hazards to other parts of the building because they don't realize that the fire sprinkler system has differentiating factors, that they can't move stuff around because they decided these products work better over here than how we originally planned it. So the codes don't really allow you to base the protection on the mix, just based everything on the overall greatest demand. There are circumstances where you can do the opposite, but there has to be absolute segregation, 4-foot aisles, and it's not good for the tenants to have to experience that. If you have a tenant that stores rubber tires, these are a very, very difficult product to ignite, but very difficult to extinguish or control. There's a separate chapter for storage of tires. Same thing with rolled paper storage. Rolled paper tends to absorb water and expand, which creates a very, very tough situation. We've actually had buildings collapse when these rolled paper, rolls of paper absorb water, expand, and push the walls out. So there's some special stuff there. don't know that Houston is known for a lot of roll paper storage. Plastic motor vehicle components are also a special thing because they're made of ABS plastic, but the manufacturers inject a fire retardant chemical, so they become less flammable and lesser of a challenge than just a regular Group A plastic. So I just want to give you an overview of why the differences occur, why the different heat release rates impact the kind of fire sprinkler system that you're going to have in your building. Most people have pallet racks. They go into a 30-foot building because they want to store higher, because they're paying by the square foot for their lease. They're not paying for the air above the floor, they're paying for the floor space. When they have pallet racks, they have to have flue spaces, both through the long way of the pallet rack back to back, and transverse flue spaces, which is to say I'm standing in front of the rack looking through the rack, because those flues are going to, oops, what happened there? Why am I going in? Oh, I know I'm going in reverse because I'm stupid. Okay, because in the pallet rack, the flames are we want the flames to climb, not spread horizontally. That's going to become more challenging. So if I have the pallets too close, or if I have solid shelving, it's going to force the fire to expand or grow horizontally instead of vertically. But my best scenario is to have those flue spaces that allow the flames and the heat to climb, and then the water from the ceiling sprinklers to cascade down through those unit loads and get water to the base of the fire. And frankly, the quicker we do that, the better off we are, because the faster we do it in the timeline, the less heat release rate we have, the smaller fire we have. So we care if we have open racks versus solid shelf racks. Now, don't assume just because they have wire mesh on their racks that it's open, because if they put the unit loads or the pallets closer than 6 inches apart, they take away the flues and then they become solid shelf storage, even though the pallet rack itself is open. So the material you put on the rack can cause you to be solid shelf, even if you don't have a physical shelf. Again, probably not something you're going to care about, but those are the things we're going to have to discuss with your client to ensure that the building matches their need, or that the fire sprinkler system within this building matches the need. This is called palletized storage. So everything's on pallets, and those pallets, create a space for the forklift to come in and move the unit load. These pallets are going to form a horizontal space between the tiers of storage for the fire to travel through, if you will. But for the most part, these fires are going to be on the faces of these cartons or of these blocks of storage. This is shelf storage, usually 30 inches wide with 30-inch aisles. And again, these are solid shelves. Those 30-inch aisles are critical. Sometimes you'll see this in back-to-back. This is typical rack storage. This is called double row rack, because you can see that there's 2 rack sections back-to-back. Sometimes you'll have clients storing 3 or 4 of these, which is called multi-row rack. But this is pretty typical of what we see in most warehouses. Now, depending on the sprinkler system that they have in the building, there's a certain amount of clearance required at the top of storage to the sprinkler, so that the sprinkler, when it discharges water, can develop a pattern, and that pattern of water spray is not restricted because the storage is too close. We also have the other challenge where the clearance above storage is too big, and the fire's growth or the heat cone can be much larger. So we have both issues. That's why we need to know what's the storage height and what's the ceiling height. These are portable racks on the left. They can be stacked on top of one another or configured in various heights and various configurations. And on the right, we have movable storage, which is where you'll find the Houston Police Department probably uses this kind of storage to store all of Bradley Elliott's speeding tickets, so that, they can move the racks and add more and more tickets each month. We also have what's called low piled storage as opposed to high piled storage, and that's a little more forgiving in terms of the fact that we have lower storage, so we're not going to have that fire climbing up very rapidly. But again, then now I am going to delay the activation of the sprinklers because there's so much volume of space for the heat to get to the ceiling and open the sprinklers directly above the fire. I mentioned that storage can only occur in buildings where the ceiling slope or the roof is 2 and 12 or 16.7%. If you have, I don't think you'll have many warehouses where you have a steeper pitch of the roof. It's more common in areas with snow loads, but I just wanted to mention that that is a restriction. If they have high velocity, low speed fans in the building, which is more and more common, when the sprinkler system operates, there's a flow switch that tells the alarm company that water's flowing. When water flows, these fans have to be shut down automatically. And the reason for that is because they move enough volume of air to disrupt the flow of water from the sprinklers that you see that are adjacent to the fan. So that when you have these high velocity, low speed fans, when the sprinkler system activates, the fans are required to shut down. In these warehouses, you'll see these small hose connections that are connected to the fire sprinkler system. Nfpa 13 no longer requires these, and if you have them in the building, the local fire authority can allow them to be removed. First responders will not use fire hose that is owned by the building, not owned by the fire department. Predominantly, that's because they can't trust these hoses. They're of low quality. They're not lined or jacketed. They're just basically a cotton hose. They're not maintained. And unless you have a charged hose that has been tested in your hand, you're not going to go into a burning building to save boxes. They'll go into a burning building to save life, but not material. So for the most part, these small hose connections were put into buildings back in the day when the warehousing company had to train their people to be a fire brigade. With OSHA rules being what they are these days, unless people are trained to use this equipment and have proper PPE, then we don't want the equipment in the building. So a lot of times people who know about ESFR sprinklers ask me, why don't we just put in ESFR sprinklers? They're the best. We don't have to put in rack sprinklers. And why don't we just do that? Well, the answer to that is you can only use ESFR sprinklers in open racks with no open top containers. You can't have solid shelves unless you add in-rack sprinklers, and they won't protect flammable or combustible liquid storage. Plus, you can only use ESFR sprinklers in a wet pipe system. Most of you probably know that gas will float on water. So any combustible or flammable liquid will be lighter than water and float on top. These sprinklers put out about 100 gallons of water per minute. So voluminous amounts of water coming out of these sprinklers. And if I have flammable or combustible liquids, they're literally going to be on fire, floating on the water and spreading the fire in the path of least resistance for the water. Wherever the floor is not level, the water is going to carry the fire to other parts of the storage occupancy. So for that reason, I have all of these restrictions. A lot of developers ask me, hey, can't we just put in ESFR? Well, you could, but not the best choice because you're going to have clients who don't qualify to have an ESFR system. I mentioned in-rack sprinklers. In-rack sprinklers, this is what that pipe looks like before it goes into the racks. And here are these little, I referred to Bambi as the head guard on the sprinkler. When you see these in the racks, you see these water shields on top. You see these little caps here, if you will. These are not heat collectors. what these are doing is shielding the sprinkler from the water droplets that might fall on it from above, from the ceiling sprinklers. Because if you get even a drop of water on the seat of the sprinkler, it's going to act as a heat sink and delay the activation of this sprinkler until that water droplet or pool of water on this little cap here, until that evaporates. So you don't want that delay. So it's not uncommon to have in-rack sprinklers, even when you have ESFR sprinklers. So I went through all of those slides in as big a hurry as I could so that I could leave this remaining 20 minutes for as many questions as you might have and want to talk about. But I want to overemphasize what you need to know, the most thing you need to know about these fire sprinkler systems. Most of the warehouses, especially around big cities like Houston, most of the warehouses are spec lease buildings. They aren't built for a specific tenant who we've looked at the fire sprinkler system and designed the fire sprinkler system based on their exact need. But rather, we're looking at, what you guys, I think you guys call flex space, what we on the West Coast called speculative lease. So we have to match the tenant to the building based on the fire sprinkler system, or we have to evaluate the fire sprinkler system for the adequacy based on the client need. In order for a fire safety professional to make that determination, they need to know how big is the building, how tall is the building, what does it say on the hydraulic data nameplate so that we understand what this system was designed for. Then we have to, we have to talk to the potential tenant and find out what their immediate use of the building is going to be. What are you storing? How are you storing it? Where are you storing it? Are there going to be some changes to the way you store things, packaging changes? I'm a pretty old guy. I'm in my later 60s. When I was a kid and you got a TV, it was a big CRT and it came in a huge box and it was full of styrofoam blocks, right, to protect that television. Today, you buy a television and it's a flat screen, flat panel. It comes in a very thin, lightweight cardboard box, and there's a couple of 4 little formed cardboard protectors holding it in place. There's not much else in the box. There's not as much Group A expanded plastic because it's not green. It sits in the landfill forever. So lots of companies have changes coming in their packaging or their product. And so you want to be asking all these questions. And since you as an agent or you as a manager of a building are not experts in this field, and you shouldn't want to be one, my recommendation is that you find somebody you like to work with locally, whether it's a fire sprinkler contractor, a fire protection engineering firm, or somebody of that ilk, and get them involved as early as possible so that you can evaluate the system design and the client need and ask the appropriate questions about what they might be doing 5 years from now. They might not know, but you can ask as many questions as necessary to make sure that they're not interrupting the business 2 years down the road, because the fire sprinkler system is the stepping stone. The good news is that most of these buildings, most of the developers put pretty robust systems in buildings that are relatively newer. And by that, I mean the last 10 years, more enlightenment and more opportunity, because they understand that the better sprinkler system they put in, the more opportunity to lease tenant spaces to potential clients. If they put in minimal systems and expect the occupant to upgrade the system, well, they're probably going to lose opportunities to lease their space, because no startup business wants to spend their money improving someone else's business, someone else's building. So they've gotten a lot smarter and a lot better about putting in systems that are more robust in the first place. So I'm not sure that my perception of the information you're looking for is the right perception. So here in these last 15 minutes, I would ask you to either ask questions in the chat or raise hand and have Natalia acknowledge you, and we can just do Q&A and see where this goes.
That sounds great. Okay, so we do have one question that was submitted in the chat, and it asks, if there are multiple systems, are there also multiple hydraulic system tags for each one?
Absolutely. There will be that hydraulic sign on every riser. And by the way, the standard for inspection, testing, and maintenance of all of the water-based systems, that includes your fire pump, your fire sprinkler system, standpipe systems, all of that is covered in Nfpa 25. And unfortunately, if that hydraulic data nameplate, if that placard is missing, that is a deficiency in your annual inspection. And someone is going to have to find the original drawings if they're available, or you're going to end up paying someone to come out and survey the system and recalculate and recreate that card to be in compliance with Nfpa 25, which is the standard for inspection, testing, and maintenance. That is a great question, by the way. So I'm assuming, because BOMA stands for Building Owners and Managers Association, and most of you are managing buildings as opposed to being leasing agents. And I wasn't really sure, what your interest level was in the knowledge, not just of storage occupancies. I do want to note that fire pumps, if you have a fire pump, and a lot of storage buildings do, especially in Houston. So Houston's a little unique in that it requires a break tank. So when the water comes into the building, there's going to be a big square water storage tank. And that fire pump is going to suck the water out of that tank while the municipal water supply fills that tank. There's also something called a backflow preventer. All of these things require annual testing and certification, and that should fall to the tenant. It won't fall to the owner. It's like anything else in a triple net lease. The tenant is by default the owner of the fire sprinkler system and bears the burden of inspection, testing, and maintenance criteria and compliance. I don't know why, but dead air bothers me. So I know I had 38 slides. When I first put this together, I had like 75 slides, and I thought to myself, I'm not going to get through that in an hour. So I tried to pare this down and anticipate what your questions. I see there's a second question in the chat, Natalia.
Yes, there is. What do you find is a tenant's biggest challenge to getting their high pile permit?
Well, again, being a West Coast guy, on the West Coast, before I became the president of the American Fire Sprinkler Association, I was a consultant. And what I did mostly was write high piled storage reports for the submittal of the permit. So the fire departments on the West Coast will not give you a permit without a high piled storage report from an expert like me, hopefully a better looking one. But what I would do is sit down with a client and go through everything they never wanted to know about their storage. And in some cases, I'd make recommendations. For example, there's a company in Encinitas, California called Nixon Watches. And they were mostly, they sell watches to skaters and surfers. So that kind of youthful generation. And they had these watches, and they were in polystyrene blocks, in these boxes. And I'm like, guys, are you serious? Your client base has an interest in not having this stuff in the landfill. So let's change the packaging to something more, earth friendly. We went to the fire department and said, hey, this is the packaging today, but it's not going to be tomorrow. So can we design your fire sprinkler system based on what we're going to be doing? And they agreed to that. And they got to put in a much less costly system. So I don't know if the city of Houston requires a third-party report, but I certainly recommend one. Now, if you're an insurance company, for example, if you're a factory mutual risk, not you, of course, the BOMA member, but of course the client, if they have an insurance company like Factory Mutual, those requirements are going to be more robust than the adopted fire code in the municipality where you're moving. So now you have to serve two approvals, your insurance carrier, as well as your local fire department or fire prevention bureau. But the good news about that is you can take your insurance company requirements straight to the fire department in lieu of a report from a technical expert like myself. So if somebody is under those circumstances, there are a number of very reputable fire protection engineering firms, and they're not difficult to find. If you're using a space planner, they probably know who to call to get that kind of report. If not, you can always reach out to us at AFSA. We can make a number of recommendations so that you can get a couple of bids on whatever it is you're doing. But the best thing to do is get somebody involved who is going to allow the continuity of the business practice so that you're not going to be interrupted. Your end user, your tenant, or your owner is not going to be interrupted in their business practice because they've got this pain in the butt fire code thing that they didn't even know existed. I mean, I know people who own buildings and they get cited for something and they're like, I didn't even know we had a fire sprinkler system. What the heck are you talking about? And that actually happens all the time. So I've hopefully avoided answering that question.
One more came up. Talk about flammable liquid storage and what systems are required for those. Also, is there a volume of flammable liquids that triggers high levels of suppression?
Yes, that's a great question. So combustible and flammable liquid storage is covered by Nfpa 30 and Nfpa 30B. That's a whole different cat. When we get into high hazard situations like that, there's going to be multiple things that aren't just fire sprinkler system related. For example, secondary containment. So when you've got vessels or containers, which could be as small as pints or as large as 55-gallon drums versus vessels that are pretty good size that are inside or outside of buildings with flammable combustible liquids. The code requires us to take the largest container plus 30, 60, or 90 minutes, of water from the fire sprinkler system and have secondary containment. So I need to dish the floor or have a container subterranean so that all drains fill that. So the fire, we want to contain all of that hazardous material plus the water that's now contaminated. And after the fire is out, then we want somebody to come along and take that hazardous material away from the site. In some cases, instead of water, we're going to attack that fire with foam, aqueous film forming foam, or AFFF. There's a number of issues. And by the way, if you have external storage of these vessels full of flammable combustible liquids, then you're going to take the highest volume plus the greatest 24-hour rainfall on record, and you're going to build a dike, a containment field around that vessel or around those series of vessels around those tank farm, and you're going to have to capture the rainwater plus if you have one of those deluge systems, all of that water. So when we look at that, there's a lot of rules about the distance away from walls, the distance away from property lines and driveways and public right-of-ways that those vessels can be. But if we're just talking about a standard storage facility where they're taking flammable combustible liquids and reselling them, then there's a huge difference between whether or not you have a cash register in the storage facility. Because you go to Home Depot, let's go to Costco or Sam's. We have all this vegetable oil stored in the racks. Vegetable oil is really highly flammable, and they can actually store as much as they want because it comes into the facility and it's sold from the facility without ever opening it or having it in open use. So in those circumstances, I have to evaluate the storage containers. And if there's open use, like in a manufacturing, so I've got storage on this half of the warehouse, I've got manufacturing on this half, and I'm openly using these chemicals in a process, those are going to kick in some extra conditions, if you will, both for the fire protection systems as well as for the variations in building. If you've got flammable combustible liquids that are just being stored, there are what we call control areas. Each building's allowed to have up to 4 control areas, and the amount of each one of those is limited in each control area. I talked about commodities earlier and how we protect those. Well, with flammable and combustible liquids, based on the flash point, they're listed or classified as flammable liquids 1A, 1B, 2A. If they're combustible, then those are also classified as 3A and B and so on. So think about this. If I take a match, if I have a 5-gallon bucket full of diesel fuel and I throw a match in that, it's going to go out. Same 5-gallon bucket of gasoline, I throw a match in it, you don't want to be there. A flammable liquid is much more volatile and treated differently in terms of how much you can store than a combustible liquid. And it depends on the size of the container and all those issues and whether or not they're resold or used in the building. So it's a very complex question. I'm glad you asked that question. But the first answer to every question in fire protection is depends. Depends on what they are, what they're doing with it, the sizes of the containers, the method of the storage, whether or not there is open use. That's when you really need somebody who's an expert in this field to determine the best way. So if you've got flammable liquids that are in open use, then you know you have vapors, and those vapors are going to travel along the floor. If somebody has shoes with a nail in them and they make a spark by hitting that on the concrete, you could have an explosion in that area of your building. So you're going to have intrinsically safe electrical outlets and lamps and lights and a whole bunch of other environmental controls than if you're just moving stuff around in 55-gallon drums that you're storing and reselling. So it's a very, very complex question, but I hope I've chewed around that enough to give you a sense of the need there. Another question just came in.
No, it's just a comment. It says that her answer hurt.
Does the comment say Bob talks way too much?
Absolutely not.
Oh, good. Well, again, I did try to tailor this so that we had some good time for conversation, and I didn't want to bore you to death. I'm sure some of this is boring, but I promise you having this basic knowledge of the need and the variety of needs is going to help you help those potential tenants that you're putting into buildings or manage those potential tenants. When one of your tenants is renewing a lease, that's a great time to ask if anything has changed. Have they made modifications to the building or to their product? Have they added pallet racks? Did they used to do palletized storage? And if you see changes in what they're doing, you might suggest, hey, this might be a good time to reevaluate your fire protection system, making sure that you're safe. It's very, very common for things to change over time. So again, these are pretty important things, but they're often overlooked things. That usually causes some problems. So Bradley and Natalia, thank you both for having us. And if we can do anything else for you, you see my email address. We have a full staff of fire protection engineers. We are here to help you. We're not running up a bill every time somebody calls us with a question that we can help guide you towards some solution.
Thank you so much, Bob. Thank you all of our attendees for coming. As I said at the start of the session, we'll share Bob's PowerPoint PDF, and please feel free to reach out with questions. And if you do have any thoughts or ideas on how we can continue to build out, programs and products and services for our industrial membership, please reach out to us. Thank you.